Good morning, girls. Today we are going to discuss about linked queues. So in the last class we have discussed or we have seen how to implement a stack using linked list. So that is called linked stack. Here we will see how to implement a queue using a linked list. So same this this excuse me so this also got the name because the queue is being implemented by linked list, so we are calling it as linked queue. The same drawback as if we can implement these queues also using arrays, but as these arrays can't grow dynamically depending on the requirement of the programmer or the program. Actually arrays are of fixed size, so because of that limitation, we are implementing queue using linked list. So see, so the fixed sizes do not give flexibility to the user to dynamically exceed the maximum size. So as uh, required or depending on the requirement, we can't increase the size of the array because it is fixed during the implementation or in the program itself. So that is the reason, or that is a drawback of implementing queues using arrays. So we are implementing queues using linked list. So this the declaration of arbitrarily maximum size leads to poor utilization. The same thing in the stack also. If we declare a very big size of array to implement a stack or queue beforehand, if we don't utilize it in our program, that amount of data is not stored in the array, so it is called poor utilization because we are not utilizing the amount of memory that we are allocating. So to overcome this, excuse me, we are implementing queues using linked list. And also one more drawback of this implementation of linked list, sorry, implementation of queues in arrays is updating the front and rate. So um, to implement the queue properly, the shifting has to be done to the left and necessarily and frequently. As when you want to insert a new data mm, at any given position in an array, the elements have to be shifted, and all the elements have to be shifted to queue place to one single element. So which all has to be done frequently. So to avoid these problems like poor utilization of the sorry dynamically, we can't increase the size of the memory, and in inserting the or updating the front and rear um, positions of the queue is difficult. And also when you want to insert a new element into the queue, the shifting was very much difficult. So to overcome these, we are implementing queues using linked list, which is called a linked queue. So this is how the nodes in the linked list look like. We have already seen. So this is front pointer, and here we are also using the second pointer called rear pointer, which is pointing to the last node in the list. So a stack will have, instead of front, you have a top pointer there. Here we are naming it as front pointer. So front pointer and rear pointer denote the first node and last node, or point to the first node and last node of the linked list respectively. So in by implementing queues in the linked list format, insertion and deletions of the nodes becomes very easy, and this is what is the advantage of implementing linked list in queue. So this is how you are writing a program. So just you are taking a student class, and this is the data that you want to store in that particular node. So roll number, name, and data. This is the data that you want to store in the node. Roll number, name, and year, branch, all these things, and you have defined data types. And the student is a link itself. You are pointing, you are declaring it as a pointer variable, because you have to point to the next node of the list, which itself is a link. How do you point to the next node in the list? By using a link. So you are defining the student as a pointer variable. So this is a self-referencing pointer variable. Next, class Q. So you are declaring two pointer variables, which is front and rear, and defining a constructor front and initializing the constructor to null, because in the when you declare a linked list and you don't insert any data, then the list will be empty. So to represent it, you will be initializing them or setting them as null. Front is equal to rear is equal to none. Next, so linked queue. So let us let us see how the nodes in the queue look like. So again, you are declaring a node, queue node. So this is the data. Actually, here we have defined it as student. Here we are defining it as queue node in general. So excuse me. So this is data, and this is again a self-referential link. Next, you are declaring two pointers, and you are defining or declaring a method which is not given the body is empty. And next, we are initializing these variables through constructor, and you are using some methods like add element, delete, to read the first element of the queue and to delete the queue. So all these are your methods or operations that you work, the operations which you perform, which you want to perform through these methods on the queue. So E is empty, so you're checking whether the queue is empty. Front is equal to null, you will return 1, else you will return 0. So if front is null, there is no empty, so there is no element in the list, so it automatically signifies that it is empty. So if it is not equal to 1, you will return 0, that is, there is some element in the list. So each node contains declaration and the link pointer to the next element in the queue. This is the main thing. Along with the data, we have to store the link to the next element. Then only we can traverse or we can move from one node to the other node in the list. Excuse me. Yeah. This declaration creates an empty queue and initializes the front and rear to null. So we have seen when you're first creating the list is empty, so you have to initialize them to the pointers front and rear to null. So front always points to the first node of the queue and rear points to the last node of the queue. So this is the name itself is suggesting this is what you have seen in arrays also. Always the first one, front points to the first node of the queue and rear points to the last node of the queue. So QMT is checked whether the queue is empty or not by comparing front with null. If front is equal to null, it returns 1. If it is not null, it will return 0, which is signifying there is nothing but false. So you will check whether whether the queue is empty or not by these conditions. Next, if front element is different from front. The front element returns the data element at the front of the queue. So the If you want to read the data which is in the first node or the front node, then you will use this front element, which will store the data which is at the in the front, first node of the queue, which is pointed to by the front pointer. So here the front is not updated, only element just reads what is at front. So in the front so in the front node, whatever data is there, that data will be read by using this method front element. Okay, so by using this get front method, you will read the data. Actually, it is front element. So if you check, if it is not empty, it will be returning the data which is stored in the front point. The new node. The first node. Note that if the new node is not the node getting empty, added to the empty queue, then along with the red, the front should also be updated to the newly added node, because that is the only first element. Because initially the queue is empty. You are to that empty QR, you are adding a node. So you have to set, or you have to make the pointers front and rear both point to the newly added node. So both front and rear will get updated. So see here, this is how you are declaring a new node, and you're allocating the memory. So you are putting some data into the data part of the new node, that is X, and this is the link or part of the new node, which is set to null because there is no other node. There is another node, and you will change this link part. You will insert the pointer value into this link part. So if the new node is getting added in an empty queue, the friend should be set so as to point to the new. So if rear is equal to null, front is equal to new node, rear is equal to new node. Rear is equal to null. Why? Because there is no another node after this node. So the rear pointer is null. So you are updating or setting both of them to the newly inserted node. If rear is not null, so the rear link will be pointing to the new node. So rear is equal to new node. So this points to the next node, which is after the front node pointed by the front pointer. So delete function. So how you delete, how the delete function happens, or what does the delete function do. So the delete function first deletes the data which is present in that particular node, and then it will try to delete the node. And there is nothing like delete the node, it will just empty the node, and automatically the memory location is added to the free pool. So delete gets and returns the data at the front of the queue to the caller function. So first it will verify that if there is any data element in the queue. If there is an element, then it will return the data at the front of the queue to the caller function. So the front is set to point to the new queue front node, which is next to the node being deleted. So if you are deleting So if you're trying to delete this node, the delete will return the data which is at this node, and this pointer is set to, a front pointer is set to point to the next node in the list. Yeah. So if the last node is being deleted, then the delete node's next pointer is guaranteed to be null, because it is the last node. There is no further node. It is the end. It is specifying it as the end. It is uh, declared as the end. Last node is pointed to by rear. So rear is null. So automatically the um, last node, if it deletes, if last node is deleted, the delete node's next pointer is set to null, is set to be null. Next, If the current deletion of a node results in queue empty state, then along with the friend, the date should also be set to null. So if you're deleting a node, when you're deleting a node, if it is a one and only one node in the queue, I mean there is no node any other node left in the queue, or if you delete that particular node, if there is no node left in the queue, then the queue will be empty. Then the front and rear, both the pointers should be set to null, which signifies that the queue is empty. So this is how you will be seeing the delete operation. So queue node is current is equal to null. So you are taking a temporary variable, you are checking whether it is empty. So temp will take the data which is in the front node, or the node which is pointed to by the front pointer, and current is set to front, and the link which is in the front is the actual link which is the front pointer which is pointing to the current node will be set to the next this front link is nothing but the link of the next node, so it is set, the front is set to the next node, next delete current, so the current node will be deleted. So if front is null, there is null, so return temp, so the a whole just say is list is empty, so you will just return the data which is that is what we have stored from the node into the temporary variable and display it. So to read the front element, this is how you read the data. So you will be reading the data which is in the front node or the first node into the front element, and front point variable and display it. So this is how you're adding, and next you delete. So 11, 12, 13. Uh, so this is how you will be deleting and adding the elements in the queue. So I'll add, next delete, and next you are adding, and next you are deleting all the elements, and next finally you are adding 15 and 16, and you're also deleting them. So this is how you will use a linked list to represent a queue. So how you erase a linked queue, on the whole. So you have to check the whole queue, and you have to you have to delete all the data which is in the queue. You have to make it empty and release the memory which is allocated for each node. And this whole thing, traversing the node queue and also releasing the memory, is all done through a destructor. Okay, so this is how you will be emptying the queue. So this is how you will be implementing a queue using a linked list. Next, we'll be seeing what is garbage collection. Garbage collection, we generally have, we know that the thing which is not in use for a long time has to be collected, so that uh, the memory which is being occupied by those unused elements has to be released, or so that it can be used by the other programs which are in need of memory, or which wants to do some memory allocation by storing their elements. So memory is just an array of words. So after a series of memory allocations and allocations, there are blocks of free memory scattered throughout the available heap space. So we all know that the memory in the heap area grows and shrinks with the allocation and the allocation of the memory spaces. So to enable to reuse this memory, the memory allocator will usually link the freed blocks together in a free list by writing pointers to the next free block in the block itself. So uh, how we are going to maintain a list of the available space means the memory allocator will be writing a list or maintaining a list of all the pointers which are pointing to the free blocks in that heap space. Um, so when you want to allocate memory to the variables in your program, so you have to refer to that free list. So how we are going to refer to that free list? Again, some external free list pointer is set which points to the first block in the free list. So for anything which is implemented in the form of a list, you should have a pointer which points to the first part of the list. So when a new block is requested, the allocator will generally scan the free list looking for free block of suitable size and delete it from the free list, because if you delete it from the free list only, then it will be allocated to that particular I mean uh, program. Or else if it is left here without deleting, it will be again it may be again referred by another program, which will again cause or give rise to problems. So when you're allocating the memory, immediately you have to delete it from the free list. So when you're performing to the operations on the list, like insert, delete, and search, so the list uh, sorry, when you are doing the operations of insert and delete, you need this memory allocation and deallocation. So to perform all these things, uh, operating system has a separate memory management module. So this is represented by or implemented using a linked organization. I mean, this management of memory is done with the help of a linked list. I mean, this all um, free space is represented in the form of a list. I mean, which is nothing but again a group of nodes. So this list is can be called as list of available space or free storage list or the free pool. So so when some memory block is freed by the program, the space available can be used for future use. So you can't leave it like that, or which is of which makes of it of no use. So what you do, you have to add these blocks which are left freed by the memory, freed by the program to the free pool. So this technique of adding these free blocks into the free pool is called garbage collection. So this is the main term that you have to remember, garbage collection. So this garbage collection is done in two steps. First, the process runs through all the list, tagging those cells which are currently in use. So the process scans all the memory, uh, I mean, allocate memory spaces which are allocated to that program, and tags and puts a mark on them that to understand that these cells are being used currently. In the second phase, and this is first phase, this is one look at the one scan at the memory allocation, and the second scan or second phase, it will run through the memory and collecting all untagged blocks and inserting the same in the free pool. So the tag cells are in use, that is what we are saying. So tagging the cells which are in use. So the untagged cells will be taken, and those will be inserted into the free pool. So when this garbage collection takes place in two situations. First situation is when either there is overflow or underflow, then this garbage collection will take place. And when the CPU, second situation is when the CPU is sitting idle, then also the garbage collection starts. But when what this garbage collection is doing, or what the CPU is doing, it is actually not visible to the programmer. All these happens, I mean, all the procedure of garbage collection happens in the background without disturbing the program. So we have seen here that overflow and underflow are two situations where actually the garbage collection starts. So what is overflow? So when you're trying to insert a new data node into the data structure, but though there is no available space, there is uh, no available space in the memory there where you have allocated. I mean, all the places uh, are full. Actually, they may not be full because we have deleted some nodes in the middle, but they are empty, but they are not listed in this free pool unless and until excuse me, unless and until the free memory locations are listed in this free pool or free list, the processor will not know which memory cells are free. So when you're trying to insert a node, but there you are finding that the data structure is full, but here the free pool is empty. So that situation is called overflow. And next one is underflow. So what is underflow? Where the programmer wants to delete a node from the empty list. So already your list is empty and you're trying to delete a node. So that situation is called underflow. So this is about your overflow and underflow conditions where actually, I mean, when these situations arise, the garbage collection starts, or when the CPU is sitting idle. So the most suitable data structure for implementing this garbage collection procedure is circular DLL, because the traversal becomes easy in the double linked list. It can move to the left as well as right, and there is no need to again go to the front pointer, as in a circular DLL, the last link of the last node will be pointing to the link of the first node, so address of the first node. So it is very much comfortable to implement this Scave collection through circular DLL for its traversal, unending traversal, and traversing in both the directions. So this is all about your linked list. So with this we complete linked list. So in the next class we'll be starting a new topic. So if you have any doubts, do ping me in the group and we will update our notes part in the coming days. Have a nice day. Thank you, girls.